Okay, in this video, we're going to see if this series converges or not. Well, let's take a look of each term and then come with a formula, and depends on what kind of test that we're going to use, right? So here we go. Right here, let me just put down the sum as n goes from. We'll notice that instead of the inverse tangent on the top, we have 1, 2, 3, 4, 5, and so on. So it seems that we just have to go from 1 to infinity for the n values. And everybody has the inverse tangent on the top. So we must have inverse tangent, and n starts with 1 right there, so that's really nice. It's just inverse tangent of n. Good. Now, let's look at the denominator. We have 2, 5, 10, 17, 26, and so on. We have to find a formula for the denominators. All right. To go from 1 to 2, 2 to 5, the third term, right? The 3 to 10, 4 to 17. I think this right here is a pretty good clue. Because we know 4 squared is 16, and we add 1 to it, we get 17. And does that work for the next number? Yes. 5 squared is 25, and we add 1 to that, we get 26. So in another word, the denominator is just 1 plus n squared, like that. That's the denominator. And of course, if you go back to the first one, 1 squared is 1 plus 1 is 2. Very nice. So now, this is the form perhaps that we like much more. And we will just have to see what test that we should use right here, right? And imagine if this is an integral, can we integrate inverse tangent of x divided by 1 plus x squared? Yes, right? So let's just use the integral test. So here we go. We are going to consider the function. I will write down f of x, which is just the inverse tangent of x over 1 plus x squared. And you should show me a graph like on the side right here. And if you graph this, you're actually going to get like this. It goes up from the origin up and then down like that, right? Well, it doesn't really matter because when x is 1 and after that, this function right here is, of course, you can see it's decreasing, continuous, and of course, everybody is positive. So just be sure you include these details. And now, of course, to use the integral test, we have to just do the integral. So let's go ahead and check the integral. And we are going to go from 1 to infinity of the function, inverse tangent of x over 1 plus x squared, like this. All right, now, how can we integrate this, especially if you haven't done integrals for a while? Yes, we can just do a u sub for this, right? So we are going to take u equal to the inverse tangent of x, and we see that du is just 1 over 1 plus x squared dx. And notice that we have the 1 plus x squared in the denominator right here. So the 1 plus x squared here, along with the dx, all this right here will be the du right away. That's very nice. So let's take a look. Keep in mind, these right here are in terms of the x. X is going from 1 to infinity. And when you take this integral to the u world, be sure you also take the numbers as well. When x is 1, we put it here. Inverse tangent of 1 is pi over 4. So we have u going from pi over 4. And then we will put infinity right here for the x. And the inverse tangent of infinity, that's pi over 2. So u will be going up to pi over 2, like this. Now on the top, this is the inverse tangent of x. Namely, it's just the u. And all this right here, the things I colored it right here, let me just color it again in green this time, just to give you guys some Christmas color. This right here is equal to the du, right? So I just put down du right here. And now we can just totally integrate this, and this is actually really nice. Integrating u in the u world, we get 1/2 u squared, and then plug in, we finish everything in the u world. So pi over 4, pi over 2. But if you are not really interested in terms of getting the value of this integral, you don't have to worry about the result. I will still write it down for you, just to be a good teacher, I would say. Anyway, put the pi over 2 here, so we have pi over 2 squared. Actually, let me just do like this, it's easier. Pi over 2 squared, and then we are going to take this and then minus parentheses 1/2 pi over 4, and we square that. Yeah. And just do the math pretty much. This right here on the top is pi over 2. This right here on the top is pi squared, and then over, this is 4 times 2, which is pi squared over 8. And then right here, we have minus, again, pi squared on the top, over, this right here is 16 times 2 is 32, like this. And then, of course, get our little common denominator. I need to multiply this by 4 and 4, and 4 minus 1 is 3, so altogether is 3 pi squared over 32, like this. But again, this value, as long as it's finite, we know that this guy right here converges. We are not going to say the answer to this series is exactly 3 pi squared over 32. In fact, we actually do not know how big this series, how big this sum is. We don't know. All we know is that if this improper integral turns out to be finite, in other words, this improper integral turns out to be a convergent, that will tell us that this infinite series also converges. Why? Of course, we did the integral, and that's the integral test. So just write this down right here for you guys. By the integral test. And this is all you need to show. This is all you need to show. I have absolutely no idea how big this sum is going to be, but I just know that it will have to be finite thanks to the integral test. So that's it.